Good morning. It's a little early here on the west coast of the United States. It's a little bit later in the morning. In this scene here, we're looking at the Kennedy Space Center and specifically the dock at the turn basin. And this is the NASA's Pegasus barge. And actually, it looks like we can see a little bit of we can see the SPMTs, the lights flashing down here. So it looks like they really are getting ready to move this is the top 4/5 of the SLS Core Stage-3, which is pointed at Artemis III. So for the last I don't know how long, many hours this morning. They started this stream a little earlier than I thought, but they have been taking equipment off of the barge that they, packed around the stage, sort of underneath and around the stage for transport. So a week ago, it was in New Orleans, and they made the journey through the Gulf, around the Florida Peninsula, and they arrived at Port Canaveral yesterday morning, I believe, and then reached the turn basin. I guess it was a little bit after, in the afternoon yesterday, Kennedy Space Center time. So in the background here, a couple of other things. You can see parts of the Pad 39A infrastructure, some of the historical infrastructure, and then you can see the Starship pad and launch mount that is being activated by SpaceX in the background. And you can see back here the crawler way, and but those flashing lights that we saw for a minute means they've fired up the self-propelled modular transporters. There are I believe that these SPMTs, these sort of mustard colored ones that go with the mustard colored carriers, there are 5 of them, and one of them is a spare. And for the trip, they would have lowered the stage down onto mounts on the barge, and then they would have the deck of the barge has many D-rings, which they use to lash these things down and other equipment down to secure it to the deck. And so one of the things that they did once they got there was to unpack things like purge equipment to keep the electronics and other non-propellant tank equipment air conditioned, and then they would have sort of unpacked the SPMTs, and this morning they've now positioned them underneath the carriers for this system, which is called the multi-purpose transportation system. It's early, and you can see different patterns of flashing lights. And if you're close enough to them, and maybe, well, actually, I don't know if this stream has sound anyway, but you can hear they make noises when they're in different modes. But you can also see the stage is loaded front end first, and of course, then to get it off, it's backed out. You can see a little bit of the cover over the engine section transportation adapter. So the reason they call this the top 4/5 is because it's literally the top 4/5 of the stage. The stage has 5 elements. From top to bottom: the forward skirt, the liquid oxygen tank, the inner tank, and the liquid hydrogen tank. And the engine section was shipped to Kennedy Space Center several years ago. It was the first engine section shipped when Boeing expanded their production operations for core stage, and this was back when they were looking to expand to produce both core stages and exploration upper stages. And that, of course, has been, depending on how you characterize it, either been killed or suspended. But what they did back then and is still in effect today is that they now structurally assemble engine sections in New Orleans at the Michoud Assembly Facility, and then they ship them to Kennedy Space Center, and Boeing then outfits them here. And of course, the engine section is by far the most complicated element of the stage, takes the most time, is essentially the long lead element of the 5. And so it's taken them this long for various reasons to get that section ready to be mated with the rest of the stage. Now, in parallel with that, they're looking at the schedules overall and trying to do just-in-time production. So there have been issues with the engine section and issues with the top 4 fists, but here we are. Artemis II just launched 4 weeks ago, and they do have this stage now in a condition where it seems like they're going to be ready to do this final major join of the stage here in the vehicle assembly building relatively soon. We don't have a good time estimate for this but that's really the big deal here. And so it does look like they are moving now. You can see the lights on the SPMTs from time to time are solid, and as they move the stage off, or the top 4 fifths of the stage, they'll have to adjust the water that they're holding in the barge to try and keep it relatively level. But when you see the lights down here solid, that usually means that the SPMTs are in motion. And they still have the cones out here. It'll take a little while to get the to do this. Pardon me, but this is the third one of these large assemblies that have been delivered to the Kennedy Space Center, and it does seem like they're getting a little bit, not a little bit, they have a lot more experience. And so it is interesting. They talked about the offload being around this time, 8 a.m. Eastern. and so there's a lot of prep work ahead of that, but it's 8 a.m. Eastern, give or take 5 minutes, and they're in motion here. So the stage will be backed out. They'll back it out on this road here, and then they'll do basically a little 3-point turn, so to speak, and then go forward into the transfer aisle of the vehicle assembly building. So they will be entering on the south side, the low bay entrance. So in terms of directions here, the barge is more or less aligned east to west here. So this would be somewhat north to south. Same thing with the crawler way. And then it's not quite as clear how things are, what hardware is in the transfer aisle at this point. So it'll be interesting to see if we get pictures. The Core Stage 4 engine section, last we'd heard, was still in the transfer aisle, and Boeing is trying to consolidate all of their SLS Core Stage production work in High Bay 2, and so they're still building out infrastructure in there. But when they originally talked about this splitting this production off from New Orleans and moving it here back in late 2022, they talked about being able to either process or store two units either at the same time, or that was kind of the idea. And so it sounds like at this point it's going to, they're still, even though NASA leadership is already talking about a commercial world, this is still for the moment still a government owned and operated program. And so Boeing is still a contractor for NASA, and NASA still ultimately calls the shots here. And so when I was asking about, well, what are you guys talking about? Boeing, what are you doing now? To some extent, how far they take work to expand capacity or production capacity, regardless of the words that are said about Cadence, there's more to it than that. There's obviously contracts, that type of stuff. So how far they expand production capacity is a mixture of what NASA wants to do now, and then there are commercial considerations. But what's going to happen with this stage, with this unit, is we're seeing this engine section. I think it's called now a transportation adapter, but basically what it is it's the very first engine section structural element that was produced in New Orleans. This was the engine section qualification article, so it's essentially identical in structure to an engine section structure. It was shipped to Marshall Space Flight Center back in 2017. Yes, that long ago. It went through a structural test campaign. For the way that they did the structural testing for core stage, because it was so large and they did not have facilities that could test a whole stage unit. It's on the order of 65 meters long, 200 meters long without the engines. The engines, if you measure from the exit plane of the engines to the forward plane of the forward skirt, it's I think they talk about it being about 212 feet, 66 meters. But in contrast to the propellant tanks that were done, each of these they did 4 structural test articles. The propellant tanks were tested to failure, essentially. I think they called it margin testing. Those were basically optional tests, and I think they did the propellant tanks at the end of the overall campaign. But this was not tested. This, I think, was tested to the point where they did see some yielding, but it was not. They did not. I guess they were able to preserve this for at least this type of use. I don't think would be usable for flight, for instance, but it is still useful for this because it is an identical structure to an engine section structure. It has had the ability to be outfitted for transportation like an engine section. So what we're seeing here is we're seeing a barrel, engine section barrel and thrust structure, although we can't see the thrust structure, and obviously the blue Boeing cover over that. A fully outfitted engine section would have a boat tail structure on the end of it, and then after that is mated to the rest of the stage. Then they finish up all of the internal connections and external outfitting, external detailing, if you will. And that's what the rest of this hardware, the flight hardware, will be going through for the rest of the year probably. And we'll see how quickly they need it and how quickly things happen. because one of the things that happened yesterday, we're actually we're in NASA Administrator Jared Isaacman is kind of running the gauntlet in beginning last week and then into this week with hearings. He's testifying in front of the House and Senate, in front of different committees. Last week he testified in front of the House Oversight Committee, the Authorizing Committee. Yesterday he testified in front of the House Appropriations Subcommittee. This morning, in less than 2 hours, I believe, he will be testifying in front of the Senate Appropriations Subcommittee. And then perhaps, I don't know if that's the last one or if he will also be testifying in front of the Authorizing Committee of the Senate as well. But that will be what happened yesterday that was interesting. And I went ahead and asked NASA for clarification just because I thought it was news to me. But he said in testimony yesterday that the lunar lander providers, SpaceX and Blue Origin, had said to him that they would be ready for an Artemis III mission in late 2027, which is significantly later than we'd been advised over the last couple of months. And it's basically been 2 months since the new Artemis plans were originally announced. This was February 27th. And at that time, they talked about Artemis III in mid-2027. And then subsequently, in the pre-Artemis II launch media buildup, so this was basically a month ago, so March 24th, NASA did this event that they called Ignition. That was a set of briefings that were held at NASA headquarters in Washington, D.C., but then the Artemis II launch was scheduled for April 1st, which was a Wednesday, and I believe the Monday, March 30th, was when we did sort of the media NASA subject matter expert speed dating thing. So a bunch of reporters sign up to interview, ask questions of different subject matter experts for 10 minutes tops. And of course, the NASA representative for the Human Landing System program, everybody signed up for him, but only so many people were able to talk to him. But to be fair, the reporters that did get to talk to him asked all of the questions for HLS are obvious. And so one of the questions that he was asked by Jeff Faust, and who wrote about this, I don't know if he wrote about this for Space News, but I saw it in an article that was published by the Space Review. He'd asked about a readiness time frame for the HLS providers, and at that time he was told, again, this is less than a month ago, he was told they were asked to prepare for a launch in between March and June, so essentially the second quarter of 2027. So, which is sooner in some respects than mid 2027 in some ways. And so now, a month later, Mr. Isaacman is talking about late 2027. And so that was disorienting enough that I thought I should ask for clarification. Now, having said that, there are already stories out this last night quoting him on that. And so, again, if I don't believe NASA has issued any clarifications. I asked for one specifically, and to be fair, it's only, again, the typical work hours are just beginning now. So we'll see if there is any clarification or not. But that would have significant implications, because it's already a significant delay in the plans for in these new plans that are only 2 months old. And that would be if they were talking about second quarter of next year, if they were talking about March, and now they're talking about October or November, that's like a half year delay already. And so I think we will be listening for updates and refinements to that schedule. Big picture, I guess it makes sense for leadership to continue to push to get everything stacked, and we know that SLS, in particular for the Artemis I vehicle, that vehicle was stacked for nearly 2 years. And so this is something that I've talked about in previous live streams. But on the one hand, you have to wonder, why stack the vehicle why start stacking SLS in the middle of 2026 for a launch at the end of 2027? On the one hand. On the other hand, why not, if the vehicle can support can stay stacked for a couple of years, because that would still mean that you'd still be talking about the ability, again, in theory and based on a whole bunch of other assumptions, that it would support a launch into 2028. It's just that, again, if you're talking about Artemis III now in late 2027, what does that do to the plans to launch Artemis IV in early 2028? Because now you're talking about just a couple of months from late 2027 to early 2028. So now we're seeing, again, we're seeing the engine section, and you're starting to see again, some of the exterior detailing, so to speak, of the stage is still to be completed, but you can see the Plus X, one of the segments of the Plus X liquid oxygen feed line has been installed. So it looks like maybe 2 or 3, looking at pictures when it was rolled out last week, it looks like there's a couple of those. The feed lines are, it's a set of segments. I can't remember if it's up to 6, but it's several segments, and then you have all of these bolted flanges between the segments, because you're talking about cryogenic fluid. And so what's going to happen to this when it gets into the vehicle assembly building? Once they're ready to mate it to the engine section, and the engine section is already installed in this new tool in High Bay 2, which is called the Core Stage Vertical Integration Center, they'll do a 2-crane breakover operation, so very similar to what you would do with the completed stage. They will break it over from horizontal to vertical, and then they will lift it into High Bay 2. So they'll break it over to vertical in the transfer aisle, and then it'll go up and over into High Bay 2, and then it will stay suspended while Boeing unbolts this engine section simulator from the bottom from the aft flange of the liquid hydrogen tank. And then once that, that mating surface will then be prepared for then being bolted to the real engine section of the Artemis III core stage. And so once that's been prepared, and once they're ready, then the crane will then take the stage up and over the top of the vertical integration center, and then lower it down onto the engine section. And then this will be the first core stage final assembly sequence done in the vertical. And so in the past, they had to do this in the horizontal because in New Orleans there's no building that you can put a 212 foot long. There's no building with that high of a hook height, but they do have that for. They do have one at the Kennedy Space Center. So going through, looking at some of the questions here. This operation will take a little while, and so again, this is this may be one of the last one of these type of live streams. But if there's anything, if we have another live event like this that's related, I'll certainly willing to do these. This is always interesting. But so I'll have to take a break from time to time this morning. And actually, again, I know I was talking about Senate testimony. Mr. Isaacman will be testifying in front of the Senate here beginning at 10 a.m. Eastern. So, and that'll be something that we'll probably have to record and come back to. But that's something else that I'm keeping an eye or an ear on this morning. But there was a question about SRB recovery ships. I think NASA wanted to. For a while, NASA has SLS program officials have said, and of course it's shuttle derived, so to speak, that the 4-segment boosters recovering and refurbishing the cases and the hardware they were breaking even on that as opposed to anything else. And so they were basically just breaking even, as opposed to doing better from a business case standpoint. And so they deleted all of the recovery hardware from the nose of the boosters, and the intent had been at the outset of the SLS program, which is like 15 years ago now, to transition to composite case boosters, to transition to custom design, to a design tailored for an SLS, for the SLS configuration, and both the boosters and the upper stage. But it's just taken. They started with the upper stage. So again, if this SLS vehicle with the interim cryogenic propulsion stage, although again that's a question for Artemis III, but we'll set that aside. So let's talk about the Artemis II vehicle then. The Artemis II and Artemis I vehicles flew space shuttle main engines, space shuttle solid rocket booster hardware in a 5-segment configuration, and the Ares 1 solid rocket boosters. So the only elements, although they're the core elements, but the core stage was basically the new piece of the booster. Everything else was taken from existing either shuttle or constellation designs. And so the Ares 1 boosters were designed to be recovered, but I think looking at flying 2 of them together in more of a shuttle type configuration, except an inline shuttle derived configuration, because the Ares 1 thrust trace was adaptable to this SLS Block 1 configuration, they went with it. The alternative would have been even more expensive, but they wanted to move to either, again, we don't know how seriously everybody was and whether they were all on the page, but they talked about the concept of either doing liquid boosters or solid boosters. I think realistically, the Bolle design, the booster obsolescence and life extension, the next generation booster design that was in design, as the second upgrade, and is still kind of a mystery about whether that's been killed by NASA leadership or not. But that uses composite cases. It's an expendable design like the rest of the vehicle, but the thrust trace and they took the advantage of going to a clean sheet design to take out things like hydrazine. The solid rocket booster hydraulics are still hydrazine powered. One of the things they did on the core stage is they went from hydrazine auxiliary power units to a cold gas. I think that was more of a delta design, where you do a helium spin start, and then the APUs are then continue to be driven with the RS-25 engines during main stage, with the essentially the out pressure is used to turn the turbines for those. For the next gen booster design was going to use an electric TVC, thrust vector control, electric hydraulics for thrust vector control. So they took the opportunity with a new design to do a lot of upgrades, and but they also went to an expendable design. So I think, again, one of the reasons that they weren't that enthusiastic about recovering these solid rocket boosters is because they had not seen a huge financial advantage with the shuttle ones. And so that's a good question. So the question about, is it both Blue Origin and SpaceX giving the late 2027 timeline, or is it just one? That's probably the first question. Immediately after the question, can you confirm that it really is late 2027 now? But then the very next question is, okay, which one? Or is it both? So it's possible that one of them is like, we can make mid 2027, and the other one's saying late 2027. But it's also possible that one of them is saying, okay, we can barely make late 2027, and the other one is saying, yeah, we can barely make 2028. So one of them could be earlier, or one of them, they could both be same time frame. One of them could be earlier than that, or one of them could be later as well. So it could be, and again, to be fair, the mid 2027 time frame, we don't know whether, even though we see these preparations here for the core stage have already reached this point where they're getting ready to do final assembly and could be ready to stack this core stage element by the end of the year, still has to happen. So it's unrealized schedule potential at this point. So there's the question about the SRB, this 12-month stacking clock, and so if I say it that way, that's what we're talking about. We're talking about it's a generic length of time that you can have segments mated to other segments. It has to do with the field joints between the segments. And so if you put down, as you have to start SRB stacking with the aft assemblies are put on the vehicle support posts on Mobile Launcher 1. That doesn't start the stacking clock because there's no field joint mate at that point. Once you then begin stacking the motor assembly segments, which would begin with the aft center segments, those are lifted in, and you do your first field joint mates between the aft center segments and the aft assemblies. That's when those clocks start. And of course, they're individual clocks, but typically exploration ground systems, when they're doing this work with Amentum and with Northrop Grumman obviously also supporting, they'll typically start those clocks within a few days of each other. So effectively, it's the same time. So the reason that they need an engine section for transport, or an engine section structure, is because this transportation system was designed for a full length a fully outfitted, well, that's not true, but a mostly outfitted core stage. So you have what we can see now. We can see this the MPTS, the multi-purpose transportation system. You have these hardware interface structures, which is this part of the carrier up here, and then those are bolted to essentially a carrier plate, essentially. So you have these. This is a common hiss here, and then you have the forward hiss, which attaches to the solid rocket booster forward attach points on the inner tank. So if you were to without an engine section specifically, you need some type of a spacer, so to speak. Well, we can talk about that too for Artemis III, but you need some sort of a spacer to fit this, because you're talking about loads on the vehicle and mounts on Pegasus that require the hiss to be in this position. So you can either build a completely new or heavily redesigned transportation system, or you could build a spacer like this to just continue to use this existing transportation system. And so, again, I haven't had a chance to talk to folks. We did sort of the speed dating thing again last week. So, 5-10 minutes to talk to folks. And the thing is like you're trying to ask questions, and in the meantime, this unit was being, rolled out. So trying to do two things at once, not as easy as it sounds. But I don't know if this was their intent all along, that they knew that they had this. But it was a little bit of a surprise to me, because when I asked about it almost 3 years ago now, they didn't talk about this specifically. So it wasn't until I actually saw them putting it in use and stacking the liquid hydrogen tank on it last fall that it was like, oh, okay, that's what they went with. I was actually thinking they were going to use one of the simulators for the structural test articles. And so when this went through the structural testing, it had what was more like a half cylinder bolted to the top of it, so that they could apply the limit loads and ultimate loads to the structure and go through the full structural test campaign when they did that in Huntsville. And then, of course, that was unbolted. But that's why, basically, is it was probably a number of things, just maybe more convenient, but also probably more cost effective. Just made more sense to rather than build a whole bunch of other stuff to just furnish a spacer, so that you could continue to use the existing transportation equipment that they had. So that, and I, again, for a moment, to continue the spacer conversation. So actually, let me see if I think I had this sort of semi-prepared. But this was the slide that was presented at the ignition event. Apologies for I still need to do some cleanup myself. But they talked about an ICPS or a spacer for Artemis III. So we're still waiting to see about what that decision is. But Ron is asking, or was asking a few minutes ago in chat, how high a fidelity the lunar lander vehicles need to be. And I think people go reach, because it's a convenient analogy to the Apollo 9 mission, and that was something that I was trying to emphasize in this last video from that went public on Sunday, which is that for an Earth orbit mission for Apollo 9, for instance, you weren't testing landing. You weren't fully testing landing guidance, navigation, and control for the lunar lander, for the lunar module on Apollo 9, but they tested rendezvous and docking. They tested docked burns between the vehicles. How does the mated vehicle perform, and when, in that case, the command service module SPS engine was fired. How does the mated vehicle handle when the lunar module descent engine was fired? They tested, obviously, transferring back and forth, probe and drogue installation and removal, opening the hatches, etc. But they didn't test the landing systems completely, and that obviously didn't happen until Apollo 11. But then they were also in that case, not applicable now, testing staging, fire in the hole. But they also tested both spacecraft's ability to rendezvous and dock with the other. And so Apollo 9 was the first opportunity to test the command service module's rendezvous and docking capabilities. Although, I guess to be fair, actually, you know what? I guess I'll take that back. I guess because of the ConOps for Apollo, I don't know that, even though the command service module could do that, I don't know that they did that nominally. But usually the lunar module would lift off and go find the command service module. For the ConOps for this system, Orion would launch. It's similar to Constellation now, in some respects. So Orion launches. It goes and finds the lunar lander, rendezvous and docks with it. And then the crew transfers to the lunar lander. They go down to the surface. They land. They do the surface operations for however long that is. And then they lift off the moon. And then the lunar lander goes and finds Orion. So you could do a lot of that on Artemis III, depending on how high a fidelity lunar landers. But the point is, we're hearing stuff on the lower end of the spectrum, so to speak, on the left end of the spectrum, on the lower fidelity end of the spectrum, where instead of on the one hand, astronauts getting into the lunar landers, closing the hatches, undocking and flying the lunar lander away from Orion, like they did on Apollo 9 with that hardware. On the other end, you're talking about only being able to come up to the spacecraft, but not being able to dock with it. So, but both spacecraft, both Orion and the lunar landers, are going to need to rendezvous and dock with the other during a lunar landing mission. And so Artemis III would at least provide the opportunity to do that. Whether or not the lunar landers are ready to do that well, that's not fair. We don't know when both spacecraft will be ready to do that. And I think the big picture question that I was posing in the last video, and is going to be a big picture question in general, is when is that going to be? Is that going to be by the end of 2027? And the other question being, does it make any sense at all at this point to fly an Artemis mission without a lunar lander, whether that's a prototype or not? It's harder to make that argument now. It's probably an argument could be made, but I don't know how this architecture now, which is, again, the goal of Artemis at this point is establishment of a lunar base on the surface of the moon. You need landers for that. If you had an orbiting outpost like Gateway used to be, then you could, in theory, fly Orion and SLS missions that had some level of, I mean, I'm not really even sure how to describe it, but it's just Gateway was a more integral element of that architecture. Even if landing was still the ultimate goal, at one point there was Orion and SLS existed and Gateway existed without a lunar lander. So, but that's not the case anymore. And again, the priorities are now are the moon base, and so it's harder to see an argument for flying Artemis III if neither lunar lander is ready to go, and then you have to start to wonder what is a minimum level of capabilities for the lunar lander and for Orion and SLS for Artemis III as it's currently constituted. If they can't dock, if Orion can't dock with at least one of the lunar landers, is that enough? Or, because obviously the other goal here, or the other big picture goal, is a time frame. So the new policy talks about being landing by the end of 2028, by the end of this presidential term. So that's, even though they added this mission, just because they inserted this mission and have a more ambitious launch schedule, that was one of the questions: is how did that materially change this, or is it just, again, it's the point of let's go faster? I do think that has helped, or that has certainly increased the tempo of SLS production. Although, to be fair, I think that had started last year. And of course, Mr. Isaacman's nomination kind of went through ups and downs, but I get the sense that they had started to try and pick up the tempo last year, and then that was just reinforced again when Mr. Isaacman took office in, I believe it was December. Pardon me. So, but yeah, it's the schedule is still a huge question. Again, not just for the lunar landers, but also for SLS and Orion and Exploration Ground Systems. It's just, again, because we've seen, this is the third core stage build. We've seen Orion. We've seen two crew module, service module, integrated Orion vehicles assembled, and now they're working on the third. And so we know what the interim milestones look like. We have an idea about what the build looks like in total. And so when we see this milestone, for instance, even though we don't necessarily have dates and this is the first time they're going to do it in the vertical, we at least have a sense of, okay, this suggests that they're going to be ready to stack sometime towards the, probably in the last quarter of this year. And, if it's earlier than that, I don't, that's I suppose gravy for the schedule. And then the same thing for Orion. It looks like those remaining hardware elements for those two programs are pointed towards being handed over to Exploration Ground Systems for stacking sometime towards the end of this year. We just have no clue about what the schedule looks like for first-time spacecraft, and these are and with very ambitious development for Starship and for Blue Moon for different reasons. They're different designs, but we really don't have any sense of insight into the progression of milestones, what happens from one step to another, what happens from one launch to another. And so it's just it is certainly possible that that one or both of them are on similar schedules. It's just we don't have any way of verifying that right now. And the problem is that the history for all of these programs is delay. So it will be difficult to tell when programs turn the corner, except in hindsight. So yeah, changing the overall schedule and increasing the tempo has its benefits, but it's still very difficult to tell today whether there is anything, whether you will have a lunar lander ready for even this new test mission in 2027. But one of the things that I mentioned, I think there's only so far you can accelerate these builds, and so NASA had planned on having this vehicle ready, or hoped, or a combination of all of the above, to have this vehicle positioned to fly 12 to 15 months after Artemis II. Again, so when, perhaps even before, but certainly, again, Artemis III had been for the first half of the decade had been planned as the first lunar landing mission, and so there was a huge sense of urgency to have that mission ready to fly as soon as possible after Artemis II, as much as possible. And so when Artemis I was completed at the end of 2022, Artemis II was hoped to fly at the end of 2024, and they talked about that, a November 2024 date, and they talked about Artemis III in December of 2025, so more or less a year. When Artemis II was delayed from that date to September 2025, Artemis III was then positioned in September of 2026, again, only a year after Artemis II. Then, because we started to see, we got more and more data about the delays for all of the programs. Artemis II, that delay of Artemis II from November 2024 to September 2025 was at the beginning of 2024. And at that point, there were a lot of questions about how realistic, how aspirational is September 2026 for Artemis III? Is it really possible to fly that soon after Artemis II? Because that has always required a lunar lander, especially if you're talking about a lunar landing mission. So then when they delayed Artemis II to April, no later than April 2026, that was early December of 2024. At that point, then Artemis III was not given a month. That was when Artemis III as a lunar landing mission was pushed to mid 2027. So now you've gone from a 12-month interval to, again, guesstimating more like a 12 to 15-month interval. And so for the better part of 4 years, at least, if not longer, NASA has been, because Artemis III has always been of some urgency, NASA has planned on flying it as soon as a year after Artemis II, if they could. There's a lot of assumptions that went into that logic, but some of it has now happened. Now, Artemis II, they're still doing post-flight assessments. It's still initial post-flight assessments, but so far, it does look like Artemis II has been a very good mission. It certainly has been safe and successful, and so far looks relatively clean. So that's not necessarily going to be a showstopper for flying Artemis III next year. What we're looking at, SLS production, Orion production is another thing that has to happen. if they still have to finish this hardware by the end of this year in order to support a 2027 mission. But again, then it comes back to, especially now, it comes back. It comes back. Then we circle back around to the lunar landers again, and are they going to be ready to fly next year? And not necessarily to land, but really just like, again, that's why the Apollo, I think folks reach for the Apollo 9 analogy, because it's the closest to being to what Artemis III they're talking about now. But it would test, ideally, I would say, again, if you go back and look at this, these goals, let me bring it up here so I can see it. So demonstrate a multi-launch campaign. Okay, you're going to get that if you're going to even just do a rendezvous and ProxOps demo. I'm going down this column here. Demonstrate Orion rendezvous, proximity operations, and docking with the landers in Earth orbit. So Orion is at least decently positioned to be ready to do that. They have the docking. The docking hardware is on hand. That's going to be installed before that is before that's delivered from Lockheed Martin to Exploration Ground Systems. Demonstrate crewed docked operations in Earth orbit. That requires docking that requires the lunar lander supporting docking. Demonstrate increasing mission cadence with prompt turnaround of pad and ground systems. Again, we will see that's where you bring in Exploration Ground Systems in terms of turning around the mobile launcher, and then they will be in charge once these final elements are handed over to them, those being the SLS Core Stage and Orion. But they're already receiving solid rocket booster hardware. They are already processing that, and they'll begin stacking the boosters. Exploration Ground Systems Integrated Operations will begin stacking the boosters. Again, unless we hear something different, what we were hearing is they're supposed to start stacking in the summer of this year. But it does get a little bit more vague over here on the right. The spacesuits, I don't think they're necessarily. We haven't necessarily heard that they're going to talk about, or that they're talking about doing an extravehicular activity. In other words, a two-person EVA, which I think you would do just in general for safety reasons. You would have to have a working airlock. You would have to, and then those suits would have to go outside and operate and vacuum. I think they're talking more about an intravehicular activity where you get to test donning and doffing the suits. You maybe operating them on umbilicals, but it would give the crews the ability to evaluate things like that and testing them in a space environment without testing them in a EVA environment or fully EVA environment. But then if you're talking about demonstrating critical HLS and vehicle performance in Earth orbit, that's vague because you would certainly, it would be an opportunity to test their RPOD capabilities, their ability to do far field rendezvous, proximity operations, and dock with Orion, which they will have to do for the lunar landing mission. And then the permeable heat shield, that is more, that's an Orion. That's an Orion test objective. So it looks like they've they've removed the cones. It looks like they've got almost the entire, if not the entire weight and the load is now completely off of the barge or very close to it. They may be slowly getting. You can see this is the forward hiss and the MPCs underneath it. So the transportation system is the SPMTs carry the transportation system, so to speak, which again, these are just carriers, but you have these forward hisses, hardware interface structures, and then those are mounted to MPCs, which are called, I think they're called multi-purpose carriers. And it's basically a carrier panel, and then these structures that bolt to the vehicle itself. So they will, as I was saying earlier, they'll back it out. They'll back it out to out here, and this is the Kennedy Space Center press site parking lot. They'll do a 3-point turn out here, and then the forward end, they'll drive it into the vehicle assembly bin. I believe this camera is on the balcony or a balcony of the OSB-2 building at the Kennedy Space Center. So the press site would be off to the right here. And now again, you can see more of the Pad 39A infrastructure in the background. And so yes, that's the Falcon Heavy. That the weather held up that launch yesterday. I believe, if I recall correctly, that was rescheduled for tomorrow. But it was ready to go, and apparently just the weather is what held them up. But we can almost see the entire 4/5 now. You can see again, this is the liquid hydrogen tank. These are liquid oxygen feed lines, and again, the liquid oxygen tank is at the top of the stage. So this is a different orientation than I think you typically see for other types of fueled liquid stages. It's a little hard to see from this angle, but there's a lot of detailing that needs to be done. But they have done some of the things that need to be finished on the exterior of the stage are the liquid oxygen feed lines, the systems tunnel, which is down here, and it might be a little easier to see because they have sort of plastic, dark, almost like trash bag plastic covering the systems tunnel base plates. And then they'll need to finish the repressurization line, so there will be some welding that will be done. To finish those. But the first thing that needs to be done is that it needs to be rotated to vertical, and then they will disconnect the transportation adapter, the transportation adapter here, which is again just essentially it's a bare engine section structure. And then this will be mated. This upper 4/5 will be mated to the real engine section for Artemis 3. For the Artemis 3 core stage, and then that's where they can begin. They'll be in the home stretch of the final assembly, and that's really more of the milestone that I think it'll tell. Well, that's not true, but I mean, it's the bigger milestone in my mind is when they actually do that mate. Because if we were talking about this in New Orleans for the first two builds, it was mating the engine section to the rest of the stage. In this case, you're inserting some transportation activities in front of that. But really, it's that milestone. It's the milestone of when they actually lift lift the top 4/5 into the vertical integration center in Vehicle Assembly Building High Bay 2 and mate it to the engine section. And then all of those activities, in theory, would be they would be working on that whenever that mate occurs. So they'll do those mates, and then there are internal connections. So as an example, the liquid hydrogen feed lines into each of the 4 RS-25 engines. Well, those are all of the feed lines are in the engine section. The engines are installed later, but they have to connect. They will connect the liquid hydrogen pre-valves that are on the back end of the hydrogen tank right now. You can't see them here, but they are there. But they will connect the feed lines up to the pre-valves. They'll connect the, they'll do some of the final outfitting. All of those connections between the pre-valves and the feed and the hydrogen feed lines are bolted flanges as well. Once all of those have been bolted and leak checked, they will close those out with foam on the inside, again to reduce the heat loss or the boil off through those lines as much as they can. And that's one of the reasons why you see, if you look at the feed line, the liquid oxygen feed lines, those are also covered with foam. So they'll be doing those types of things. They'll be completing all of the wiring connections. The systems tunnel basically carries power data and other networking connections between the avionics in the forward skirt to the avionics in the inner tank to the avionics in the engine section. And they'll be doing a bunch of the foam closeouts on the exterior. And so as this gets closer to the camera, it'll be a little easier to see, but they did some foam sprays of these flanges between the last major join that was done in New Orleans was for these 3 elements: the forward skirt, the liquid oxygen tank, and the inner tank. Those were joined first. That's called the forward join. And then the bottom of the inner tank was mated to the top of the liquid hydrogen tank. That was major join 2. And then they started to do some foam closeouts where they spray those bolted flanges, but they haven't done the full detailing. So at some point they'll sand those down so that they have a relatively flush outer mold line. But that's still to be done, and there's still connections that they have to make across those bolted flanges, and so they still have areas for all of these flanges, even the forward join flanges that they haven't done yet, and those will all be done in the vertical integration center as well. And one of the advantages that Boeing touted for the vertical integration center versus horizontally is when you have to do this horizontally, in New Orleans, the stage is on a different set of equipment that allows you to roll the stage to give you access to different parts of the stage. When the stage is vertical in this integration center tool in the VAB, the build team will have 360-degree access. There will be areas that will be maybe a little bit harder to get to because that's where the stage is secured to the tool. But in general, they'll be able to work around the circumference on the exterior of the stage in parallel, and so they'll have better access to around the entire circumference of the stage. And the idea being that they can get more work done in a shorter period of time. But the flip side of it is that this is the first time that they're doing this, and so you would expect, again, from a historical standpoint, they will go a little more deliberately. So But the goal is still to have this ready for stacking by the end of the year for sure. I know that they were certainly talking about doing that, mating the core stage to the stacked boosters this year. So going back, and this is a good question. Again, I know this is not a question that this is not a question that NASA wants to be asked about because they want the lunar landers to be a part of this. But well, let me go back and make sure that there wasn't something else. But Steve was asking. Let's see. Steve was asking, is it too late for Artemis III to go back to being a lunar mission? If they chose, well, I guess the best way to put it is, it can only be a lunar mission if, I think under these circumstances, Artemis III could only be a lunar mission if they use ICPS. So if they were to go with a spacer, then the answer is no. And again, it goes back to that question of, is there a useful mission for that Artemis? Is there a useful mission for the Artemis overall without a lunar lander? And I don't know that again, a year ago, I think you could, it was easier to make an argument for a standalone Orion mission to the moon. Now I'm not so sure. But let's go back and actually, it looks like there were some questions above that. So I guess a little bit. Let's see. So building a spacer, again, it depends on. I'm not sure that the interim cryogenic propulsion stage is a United Launch Alliance. It's United Launch Alliance hardware, but I don't know that. I imagine they would be involved in a spacer, but I don't know that they would necessarily be the ones that would be fabricating it. It really could be as simple as a cylinder that, a cylinder that mimics the outer mold line of the stage, and the stage, the only part of the stage that is exposed is the liquid hydrogen tank, and then the two structural adapters on the forward and aft ends of the tank. So for Delta on the common booster cores, again, this Delta IV is retired at this point, but you had an adapter on the top that I believe that the payload fairing would bolt to, and then on the bottom that would bolt to an inner stage. For SLS, the forward adapter for the ICPS bolts to the I guess it's the Orion stage adapter, and then the bottom bolts to the launch vehicle stage adapter. So you would just need a cylinder that was the same dimensions, 5.1 meters in diameter, and could bolt to. And the difference between spacer and a stage is that now the connection between the launch vehicle stage adapter and ICPS can be a permanent connection, because you're not going to I don't know that there would be any reason to separate the spacer from the core stage. So if they were to fly a spacer, you would the boosters in the core stage would do their thing, and then after main engine cutoff, the Orion would just directly separate from as it does when it separates from ICPS. It would just immediately do that. So you would leave behind that entire stack with the core stage. So it would be not just the launch vehicle stage adapter. It would be the core stage, the LVSA, the spacer, the Orion stage adapter, and the spacecraft adapter cone would be left behind, and the Orion would separate and be on its own at that point. So the question is one of the questions, is it possible to continue doing the Orion 3 demo mission even without the Gateway? And the answer is yes. The Gateway lunar orbital outpost concept is dead. I don't know that I don't know that Congress is either willing or able to. I guess they are legally capable of doing it, but I'm not sure that they're willing to do it. I think it's more like the discussions that we heard, and I'm not sure there wasn't discussion, but the way that it was phrased yesterday was more of a the executive branch is supposed to work with the legislative branch. So the White House is supposed to work with Congress, and they're supposed to, by law, work together on an operating plan. And so I think the objection that was expressed yesterday was more of the fact that the White House has already unilaterally moved out on some of these things, and without Congress. And I don't, again, sometimes that's just the way the way things go. That's more of a power dynamic thing. But I just don't. I think the Gateway Lunar Orbital Outpost is going to be hard to. It's hard not to say it's dead. Anyway, Artemis 3 is a rendezvous and docking mission. They don't have to dock with Gateway, and the Gateway elements that were supposed to launch first for the first Gateway mission, the PPE and the Halo, the power and propulsion element, and the habitation and logistics outpost modules, those were pointed towards a late 2027 launch. And so those wouldn't even be available for docking under the old plan until 2029. And so that is a deal breaker, obviously, for this administration, because it won't be in power at that point, at least not in theory. So you wouldn't be able to do an alternate Artemis 3 mission to the Gateway before 2029 anyway. That was one of the big factors in all of these things, and alternative missions last year and in past years is just the reason that you were looking at our alternative missions is because of the timeline, is what's going to be ready to fly in 2027. If nothing is, then of course you're not going to have a mission. But now, because Artemis is now centered around the lunar landers, is there any mission you can fly without a lunar lander that makes any sense under that formulation? So, if either of the lunar landers is ready to support being a passive docking target, or both a passive docking target and then an active rendezvous and docking spacecraft next year, then Artemis 3, right now the formulation is an Earth orbit rendezvous and docking test, and certainly they can do that. If the hardware can support it, then yeah, they can do. They don't need the Gateway, certainly, to do an Earth orbit mission. I'm not sure that they have. So the question is about an extended lunar shelter plans. I'm not sure that they have. Certainly not for the initial landings. I don't think they're going to. I'm not sure what emergency plans they will have, other than to abort off the surface and go back to the crew transport in orbit and come back to Earth. So they'll need, it's basically the same thing as Apollo. It's like they weren't going to be able to. They needed to get back to the crew transport, and they needed to get and they needed that needed to work. And so if you had, again, the Apollo 13 accident, again, that just they were very lucky from a timing standpoint. Under a worst case timing scenario, that would have been fatal, because they wouldn't have had enough time to get back. And actually, I'm not sure. Well, yeah, they wouldn't have had enough time to get back to Earth, because the service module had been compromised and basically ran out of life within, I think, within a couple of hours of the oxygen tank explosion. It was essentially it was no longer functional or supported life at that point. So, I don't think they're going to have a shelter plan at first. If by some chance you had Starship and or Blue Moon cargo capability, but the way that the development is working right now and the priorities, they're prioritizing crew landing systems over cargo. If they were to, so the only way that you'd be able to do that would be, and then the question is whether you could have a shelter in place that is completely that could be completely activated autonomously. I imagine you could. It's just, again, is that the priority? It seems like the priority. We haven't heard Congress say much of anything over the last 6 months or so, or certainly the last 3 months since they passed the budget for fiscal year 2026. So we haven't heard a lot of people talking about the race with China because the White House has not talked about it. But we did, now that we've had a couple of House of Representatives committee hearings, we're hearing about that again. And so that still does seem to have some sway with Congress in terms of priorities. But there is definitely the emphasis and the priorities between the White House and Congress are still not completely perfectly aligned. So the White House is definitely thinking more along the lines of long-term sustainability for a moon base. They think they can. They obviously think that they can do both, but I think they're prioritizing long-term sustainability over another race. And to be fair, there is still a space program that there would still be a valuable, and there's still business to be had, even if China gets there first. And I think that's the argument. That's the quiet part of the argument. So that's an interesting question, but I do wonder with the Starship HLS design. So the question is, with Starship header tanks, how do they dock to Orion nose to nose? I guess I'm assuming that the HLS design may not have those header tanks. Since it would be somewhat of a variant. So now we're seeing, it does seem like they should be able to move faster now that the weight is transferred onto ground. So they will back it up, and the camera's tracking here, but they'll be backing it up for a little farther until they can get to the point where they can do a 3-point turn. That's an interesting question. I think it depends on which timelines you're talking about. The question is, what was the original timeline for landing on the moon? At least for this, there have been several aborted plans to return to the moon. So it depends on which one. If we're just talking about the Artemis one, then the original plan was, was sort of throwing down the gauntlet, JFK style. That was in March of 2019. So the Vice President Pence at the time said has to happen in 5 years by the end of 2024. So that was the original goal. I think, unfortunately, one of the things that has been the case throughout is that there's been the dates, the landing dates for Artemis III and now Artemis IV have always had some level of aspiration to them. I don't know that they were called aspirational dates at the time. They were just called maybe just called unrealistic. But there weren't a lot of people that really strongly believed that they were going to be able to make that late 2024 date for Artemis III back then. And of course, there were delays across the board for SLS and Orion, and those didn't fly until the end of 2022 for the first time together. And so then that was the progression of dates. So again, as Artemis III, when Artemis III was the first lunar landing, the dates went from, late 2024 to late 2025 to September 2026 to mid 2027, and then that gets us to this year, and then they changed the landing to the official landing date to Artemis IV and early 2028. But the realistic dates are harder to get because those are considered pre-decisional, I guess, to some extent, or just embarrassing, because none of those dates, except none of the previous dates through Artemis III lunar landing in mid 2027 was realistic. And it's just a matter of time before all of them have officially, we will pass through September 2026, and we will pass through mid 2027 next year, but we'll pass through September this year, and all the programs will have missed that date too. So this vehicle and this hardware that we're looking at right now isn't going to fly Artemis III in September either. But again, there's a sort of a out of sight, out of mind quality, or whatever you want to call it, to some of these dates. So it's like, well, if you blame one program for a delay, does that mean the other programs were okay? And certainly for all of the dates through mid 2027, that the answer is no. They were all going to be delayed regardless. And so none of them are, it wasn't just Orion and SLS. It's also, again, the lunar landers. None of them are going to be ready in September to fly a lunar landing. And of course, now we're all wondering if they're going to be ready in 2028. Yes, and then as Ron is saying here several minutes ago, again, I'm behind chat as usual. But yes, in fact, Mr. Isaacman talked yesterday in the House hearing about a higher fidelity test of the Axiom Space EVA suits on the ISS. So I think the idea is they would do a full extravehicular activity test of the suit using the ISS airlock, using all of that infrastructure. That's I think they're planning on doing that, but I think they're still trying to meet an Artemis III date and at least manifest a suit and do some level of testing. But of course, that's going to require, there's no room on Orion to fly one of those suits, I don't believe. I mean, without taking I guess you could try and find some room, but I think I would assume the plan would be to fly that one of those suits, or one on each, would be to fly them on the lunar lander prototypes. And so if that's the case, then the only way to test those is for there to be a lunar lander ready to fly Artemis III as well. For the first lunar landings, the plans used to be, let me just double check, but the plans used to be for 2 crew to land on the moon, and so that's still the case for the now Artemis IV. They didn't provide a slide, but I would assume that that's still the case, that for the time being, the first lunar landings are going to be with 2 crew, and 2 crew will stay in Orion in orbit. At some point, when they have enough infrastructure, then all 4 of them will go to the surface, and Orion will just orbit uncrewed. And the advantage there is that would extend Orion's ability to stay in lunar orbit, because most or all of the, I think maybe with the exception of like propellant, most of the limiting consumables on Orion have to do with a presence of a crew. So things like oxygen and water, and the consumption of those would be minimal when the crew is not there. So I'm going to take a quick break here because I have to do some morning activity coordination. So I'll be right back. So one of the questions in chat is about whether this barge was used to transport shuttle external tanks. This was the last of the barges. I believe the previous one was retired, but then the Pegasus was used for shuttle external tanks. However, it was heavily modified because the external tanks were much shorter than the SLS core stage, and so it actually went to dry dock, and they lengthened it in order to do this. So yeah, that's the question again, as I'm trying to catch up here in chat. So again, we see them backing up here to do this little 3-point turn. I guess they're essentially in that now. But yeah, so Steve was asking, I guess that's sort of the tension is, do you fly SLS and Orion? What's more important? Is the cadence more important than the lunar landers? And so again, it goes back to that question: would you launch? What's the is Cadence a higher priority than the lunar landings? Because that would be part of that decision. Is the tension is between, if you don't have a lunar lander ready, but you do have SLS and Orion ready, which is, again, I suppose, somewhat ironic, since, again, there's a lot of back and forth about, well, about delays. And so, again, to be fair, SLS and Orion have been around for a much longer time than HLS. They got a lot more money than HLS from government anyway. But they're on different timelines still, and that's maybe part of the reason why. And we still have to see whether it's whether this is ready at the end of the year. Who's ready at the end of the year, but they've been through a couple of builds now, both Boeing with the core stage and Lockheed Martin with Orion, and then the rest of the hardware. Because the rest of the hardware besides the core stage, more or less, is shuttle or constellation derived, that hardware, you can see that dividing line between readiness of the shuttle or constellation era hardware and the core stage. So, the rest of the SLS elements have been ready for years. Even if the third ICPS is not used on this mission, it was delivered to Kennedy Space Center in 2023. The boosters for Artemis III were finished and put in storage in 2022. The space shuttle main engines have been ready for even longer than that. So, there's a lot of these different timelines. But I think that's where the conflict or the tension is going to be, is what do you do if you have a stacked Orion and SLS vehicle a year from now and there's no lunar lander ready? Do you launch it, and what are you going to do with it? So it would probably be, I guess, and one of those obvious questions would be, let's say they choose to fly a spacer because there's no lunar lander mission in Earth orbit that requires the ICPS. And then there's no lunar lander. And then if we go down that line of thinking, which again, I'm a little skeptical about, but if for some reason they thought there was a mission that they could fly with Orion by itself, you could destack the spacer. You would probably have to there'll probably be some modifications that you would need to do with the LVSA. Although, again, to be fair, the LVSA was put in storage. The LVSA is configured to fly with an ICPS. So you have a separation plane at the top of the LVSA, as has been the case on Artemis I and Artemis II. I think it's possible they would. I wonder what they would do with that, actually, whether they would actually remove that and put in some sort of remove that frangible joint assembly and save it for another LVSA. But you could also, you could destack the spacer, stack the ICPS, and do some sort of other mission. But again, I think that's probably 2 or 3 questions deeper than that's not the big question there. The big question is, again, do you fly it just to fly it, or do you are the lunar landers now fundamental to any Artemis mission at this point? I thought I saw the. So let's see. That one's a simpler question. So Steve was asking, did NASA use SPMTs for the shuttle external tank? No, they used. It was a much simpler, like a. But I mean, they basically used. I think they just used a truck or something like that to tow a. It was like a yoke, and but it was a much simpler. Much simpler. But again, to be fair, the external tank, even though this looks a lot like an external tank, the core stage is a full rocket stage. The external tank really was mostly a propellant drop tank. So all of the avionics, for the most part, if not literally, for shuttle, were in the shuttle orbiter. And most of the active systems, all of the command and control were in the orbiter. So there just wasn't anything in the tanks except for the tanks themselves, vent valves. But I think again, some of that stuff, some of the cycling of the valves would probably have been through even orbiter avionics. Aside from the things about the valves themselves, like cracking pressure and things like that. But with a full rocket stage with avionics and more delicate equipment in this stage versus an external tank, there were probably more, and of course they were probably over-designed to some extent. But yeah, this is being handled in a much more delicate way than the but also probably somewhat of a product of different eras as well. So Anthony's asking, yeah, that again, a lot of there are a lot of questions now with this late 2027. And so so Anthony's asking, what do you think with the new late 2027 date for Artemis 3? Do you think 2 launches can genuinely occur in 2028 given that timeline? I mean, no. It depends. I guess it depends on what they mean by late 2027. I mean, if you want to say October is late 2027, which I guess is a reasonable argument, but at the very least, it makes things a lot harder. There's just not that much time. I really don't know what they would, and the thing is, so here's one of the many questions that comes to mind with the late 2027 Artemis 3 date. Where would that mission sit on a timeline with an uncrewed lunar landing demo for both of them, for both Blue Moon and for Starship? Would that be after an uncrewed lunar landing attempt? So let's set aside the Orion and SLS Cadence issues for the moment. If HLS have finished their uncrewed lunar landing, again, I'm not necessarily saying I'm buying that timeline, but let's just say that they concentrated on the uncrewed lunar landing demos and they were somehow able to pull those off before Artemis 3 in 2027, then at least from an HLS readiness standpoint, maybe that at least would be a more plausible timeline. But again, that just means that you're going to need I think that would be the uncrewed lunar landing demo, I think, is more challenging than Artemis 3. So it's hard not to wonder out loud if they're in late 2027 for an Artemis 3 style demo, if that the uncrewed lunar landing demo for both of them would be later than that rather than sooner. But again, that's why I was surprised to say the least, about hearing that so quickly. I mean, again, it's only been 2 months since they talked about mid-2027. And again, I did notice that they started referring to Artemis 3 in 2027, and they dropped any, they increased the uncertainty from, what you might call, mid 2027. You might try and argue is anywhere from April to October of 2027. If you're just talking about 2027, now you're talking about anywhere between January and January 1st and December 31st. It's unrealistic. One of them, because the uncertainty increases, it makes the earliest date less realistic, and the later date more, and with additional severity, I suppose. So, yeah, I think really there's a lot of questions that spin off of that, if that really is the case. If Artemis 3 has already been delayed to late 2027, again, I don't even know where to start. Because one of the first questions is why. Like, are we, what happened in the last 2 months? Or was it just, I mean, again, to be fair, last year, again, before Mr. Isaacman was, I think so. I guess it was after he was renominated, or certainly they were already talking about renominating him at that point. But this is, again, what the interim, the acting NASA administrator last year, Transportation Secretary Duffy, had noted that that Starship and SpaceX had come to NASA in the late summer or early fall last year, and told them that they weren't going to be ready until either mid 28 or late 28. And so, just as we would ask the question of Orion and SLS, how are they going to go faster? And they certainly have their challenges. So again, we're looking at the third core. We're looking at the largest piece of the core stage by size, not necessarily perhaps the most complicated elements. But they're going to be challenged to finish the fourth one in the state that we saw it in a week ago. And then similarly for the fifth one, Boeing, and one of the Boeing officials that I spoke with said something to the effect of, we got to get going on the fifth one. So they have their challenges, but definitely have to wonder how. So again, Boeing's trying to speed up their production schedule and their work schedule to deliver, to finish this one that we're looking at, that's mostly completed, but still significantly not completed, and two more in basically the next 2 years. So like, we would need to see the fifth one. Need to see the fifth one of these, even this at reaching this point, I would imagine, in probably less than 2 years from now. Certainly by the beginning of 28, you need to have the fifth one ready to stack or close. But HLS, if Starship was talking about the end of 28, is the acceleration plan that's rumored for them enough of an acceleration? And again, they still have they have all of their demos to do. We're waiting for the first version 3 launch. For Blue Origin, we're waiting for their first uncrewed cargo lunar lander to fly. And then, they now have some additional investigation work to do on their new launcher. So there's a lot of questions about if they were reporting that their schedules were 2028 for last year, and you're now asking both of them to fly make an additional prototype to support this Earth orbit test flight, rendezvous and docking test flight next year. So you're asking them to do more work and get it done faster. And to be fair, NASA's asking all of the programs to do that, but the answers or the status or the evaluation is going to be different for both. And again, to be fair to HLS, these legacy programs, if you want to call them that, have had a much longer time to get to this point than HLS has. So but it is definitely going to be one of the. There's just a lot of questions about what happens now. And why, it's sort of a question of why. So if it was delayed that fast, it almost begs the question about why call it mid-2027 2 months ago. But again, as Anthony Anthony's question, I think I would almost take from Anthony's question. It's like, well, how realistic? I don't think early 2028 is realistic for Artemis 4 if you're talking about Artemis 3 in late 2027. But again, we're missing that context. So again, if you're just looking, so for Orion and SLS, or maybe it's exploration ground systems. So maybe if the third vehicle is sidelined, the third Orion SLS vehicle is sidelined and stuck waiting for HLS next year, they can certainly continue to build the fourth vehicles, the parts of the fourth vehicle that need to be finished. But it's still going to be. I mean, again, I don't know how else to put it, but impossible to turn around, to go from turning around a vehicle in a year to fly. So let's say if they are challenging Orion and SLS and EGS as programs to turn around because they have all of this additional analysis, post-flight analysis to turn around. For the Johnson Space Center to train a crew in essentially a year. They're challenged to fly Artemis III, this time next year. But maybe they could, maybe that might be somewhat realistic. But then asking them to turn around and fly Artemis IV 3 months after, maybe at most 6 months after. So again, you're already stretching things to call. If you call October 2027 late 2027 and April 2028 early 2028, you're still only talking about 6 months to turn around, and so is it just near impossible or is it impossible? But I mean, the questions are, it's hard not to hear that and go, well, let me see the schedule. That's always been the case. The ultimate goal dates are, they don't really tell you much of anything. That's all we've had for the last 5 years last 5 years, because the HLS date, even though the political date was set in March 2019, I mean, they were still talking about end of 2024 landing date when SpaceX got the Starship, the lunar lander contract. It was basically about 5 years ago. So it's hard not to say that those ultimate launch dates, official launch dates, because they are quote unquote official, even though that's still vague as blank. Those are political dates as well, and so that I don't. You could call them aspirational, as you could also call them aspirational, but the point is they don't really tell you much. You really need to see. That's why you need to see the status of hardware like we see right now. So this is to some extent self-evident where Boeing is in terms of finishing this stage, for a number of reasons. One of them being we can see the hardware, we can see the state of the exterior of it and the outfitting of it around the circumference of the stage. We're missing a little bit on the engine section, but we would get to see that from a breakover to vertical. I think that would be somewhat self-evident in terms of timeline. And then obviously, again, we have the context of we've seen them do this twice before, so we have much better idea about the context for these builds. And even if you were to say they were going to take the same amount of time to do that, that's still more information to work off of. Similarly for Orion. And the problem is for HLS, we have none of that. And so we don't have any information. And again, also on top of that for SLS and Orion, we've asked for milestone dates. As I was noting in the last video on Sunday, we asked for dates and they at least gave us some time frames. So they said they would, and we've asked leadership in the programs. We've asked public affairs. So we're asking leadership in the programs through public affairs or directly in news conferences. And so they're talking about mating the Orion crew and service modules together in the summer and delivering. And we got a little white balance there, live white balance. It's still working live white balance, but that we've heard that they're planning to start stacking the SLS boosters in the summer, that they're going to be doing the final mate of Orion, the final major mate of the Orion spacecraft in the summer, and that they're planning to have this core stage done by the end of the year and Orion done in that same time frame, and that they're planning to have this mated to the boosters by the end of this year. We just don't have any of that for, and again, the additional point on top of that is that, we still have the better part of a year and a half until quote unquote mid 2027 is over. And so as we're now hearing the date change in 2 months, we would need regular updates. So even if they gave us an update today, which would be much appreciated and valuable and provided a significant amount, depending on how detailed it is, we would need more updates, not necessarily weekly updates, even though I would say internally the program is certainly getting weekly updates on all the elements. I would say at the very least, we would need to get a decent idea about how things are going. Quarterly updates. So, if they decided not to start those until the end of this quarter, which would be basically, end of June, mid-year. But I mean, we would need to have something. We would need to have a better sense. I think quarterly updates would be a bare minimum to get a realistic sense or a reasonable sense of progress. But I don't expect that. And to be fair to SLS and Orion, I bug the programs. I mean, you can you can ask Kennedy Space Center Public Affairs for sure, if not everybody. Like, I'm constantly bugging them, certainly on a weekly basis. The more information you get, the less frequently you need to bug them. But Again, it's just my opinion. They could all do better, but to be fair, Orion and SLS, they are public programs still, so they do have some obligation, and whereas HLS has no obligation. They're completely private programs. Really, the only public part of HLS is the money, and again, the public is only partially investing in the lunar landers, but SpaceX and Blue Origin aren't doing anything wrong. It's just that we're talking about private products that are being used to accomplish a national goal. And so I think the interest is in these national goals. So Artemis 3, Artemis 4, Artemis 5, those are all national goals, and the schedule for them are national goals. So yeah, the interest, certainly if you're talking about, like, for instance, the SpaceX IPO, yeah, then there's certainly some business interest in it. But whether China beats the U.S. Or not, people are going to be interested in SpaceX regardless, and beyond, whatever happens by the end of this decade or the early next decade. If you're an investor or looking to be an investor in SpaceX as a public company, of course they will have additional disclosure requirements once they become a public company. And so there's yeah, but it is a big question. And so one of the actually speaking of that, and I need to take a look and see. I'm going to pause here, but that Senate, I believe that Senate hearing is going to begin here in the next couple of minutes. So I'm gonna take a short break and see if I can find a way to record that. So just a moment. Well, I think unfortunately I'll just have to go back and watch that. It is available there. I don't see a YouTube stream for that, or at least an official YouTube stream for the Senate CJS subcommittee. But there is a stream on the hearing page from the committee itself. So, but I will have to go back and watch that later today. But as we can see, so they've finished 3-point turn. They're getting this done. Again, they should be able to now. I'd say they should be inside the VAB here in the next hour or so, if not sooner. But this is a nice shot, and you can see the actually I can hear I can hear the hearing in the background. I'm going to go ahead and close that for now. That Senator Moran is opening the hearing right now. I'm just going to go ahead and I'm going to have to watch that later. But you can see, again, you can see the segments of one of the liquid oxygen feed lines here, and those will actually run out all the way out to here. They'll actually run from sort of the midpoint of the inner tank all the way down into the engine section. And so you can see there are still a couple of segments. There are the feed lines themselves run from the bottom of the liquid oxygen tank from the sump through the inner tank. So there are S ducts that are already installed in the inner tank. But then they'll have to there's a segment that runs from this interface here in the inner tank out. And then, so this is the top side. This is the plus Z side. This is where the tail service mast umbilicals are for the engine section. And then this is the minus Z side, which faces the umbilical tower, and that's where all of the the systems tunnel, the repressurization lines, the other liquid oxygen feed line is. And so one of the things that maybe a little bit more difficult, or is again something that you don't necessarily notice, but this is the first build that does not have the development flight instrumentation sensor islands on the exterior of the stage. So those circles that you saw, most of them were on the back side of the stage, but they use those to collect aerodynamic data, pressures, temperatures, accelerations. And so there's less DFI instrumentation on this stage, which from a production standpoint probably reduces a little bit of the time involved in doing all of the wiring splices and all of the testing that's required to verify all the different thousands of channels of instrumentation that all of the DFI works. So it's more focused now on operational flight instrumentation, but there still may be some, but they're not doing the aerodynamic data on this build. So it looks like they're crossing. What is that? Is that Saturn Causeway? But that's. But yeah, you can see some folks over there. This is the launch control center over here, and this is pad 39B where that rocket will be going eventually. One of the things that Public Affairs told me when I was asking about Mobile Launcher 1, because they rolled it back so quickly, only 2 weeks after the launch, there was some testing that I'd heard they were planning to do while they were still out at the pad. There was also some, again, I was talking to some folks pre-launch, but they were talking about, depending on the level of damage, that there were some hot work repairs and welding repairs that they were at least thinking they were going to need to do outside. But what Public Affairs said was that they could do some of that, and that the damage was much less than on Artemis 1 because of all the hardening they did, and all which allowed all the washdowns to be done. And so they can do some welding. Obviously, you're not going to do that after the boosters are stacked, but they can do that before. But one of the other things that they mentioned was a tanking test for Artemis III. And so that I thought was interesting, because I don't know that they were necessarily planning on doing a tanking test, but those plans have changed a lot since Artemis III used to be a lunar landing mission. And but I think now that we are talking about we're talking about a possible delay to Artemis III already, and if the lunar landers really aren't going to be ready until late 2027, then they may have more time to do a tanking test. And of course, if if this was going to be a low Earth orbit mission and they were going to use a spacer and not use ICPS, then you have to start to wonder whether or not they could just roll out something on top of the core stage and boosters, or whether they could roll out just the core stage and boosters and do a tanking test, and when they would be capable of doing that. If they could have the core stage and the boosters stacked by the end of the year, then maybe they could do something early next year. But again, that might be faster than possible, but also maybe faster than necessary. So interestingly, over here on the left edge of the screen, I believe that is the rotation building of the RPSF, the Rotation Processing and Surge Facility. I believe that's the rotation building, although it may be one of the surge buildings. But if that's the rotation building, that is where the two aft segments of the solid rocket boosters are being offloaded and installed in the buildup stands. And so those will be the two things that are stacked on Mobile Launcher 1 first. But the core stage is going to be in High Bay 2, where they will be finishing up final assembly. And that is still planned to take the better part of the rest of the year to finish. But if they had time to do some testing of tail service mast umbilicals, they might want, they may have time to do some of that. And I'm wondering, like, again, I see some, I'm going to take a quick peek here. Now, I thought maybe I was seeing, I see some like lighter colors or wider colors right to the left here, but I don't, that's too big to be one of the rail cars. I think, but anyway, but you can see the 4/5 with the engine section simulator, engine section transportation adapter, artist formerly known as the engine section structural test article. Okay, what that might be is that actually might be, it's OPF. Is it OPF? Artist formerly known as OPF 3. So that's what I'm seeing, is you're seeing the old orbiter processing facilities. I think it's now called the C3PF. And of course I'm spacing on the commercial something processing facility. But you can see that over here. This used to be the shuttle era SSME engine shop was adjacent to that. And then behind that, across the crawlerway, is the rotation building of the RPSF. So this is the low bay of the vehicle assembly building. High Bay 2 would be right behind the American flag. This is High Bay 1 on the inside behind the NASA logo, and then behind them you have, on the west side, you would have, in the northwest corner, would be High Bay 4, which is an SLS hardware preparation, sort of stacking preps area. And then northeast corner-ish, because this is not, I don't believe this is aligned directly north, south, east, west, but more or less. Northeast corner is High Bay 3, which is where Mobile Launcher 1 is, which is where they will eventually stack the entire Artemis III vehicle. But this is going, I think, mostly to schedule. And, then it's like, these are transportation milestones that are sort of inserted into the overall build schedule, because this is the first build that moved all of the engine section outfitting work to Kennedy Space Center. And then now, this is the first time that they're going to be doing core stage final assembly at Kennedy Space Center in the vehicle assembly building. And so what will happen next is they will, when they're ready, and I think that's why I was talking about the major join milestone being really the bigger date in terms of the overall build schedule. They inserted this transportation because they split the production. But the next major milestone for that build is the actual mate of the top 4/5 with the real engine section in High Bay 2. So what they'll do for that is they'll break this stage over. They'll attach 2 cranes to the stage, so they will be sticking the lift spider on the forward skirt flange, and then they will be attaching the trailing crane. I think it's one of the 325-ton cranes will be attached to the lift spider, and then the 175-ton crane will be attached to. They will install brackets on the engine section. To do that, they'll break it over to vertical. They'll detach the trailing crane, and then the 325-ton crane will lift it up and over into High Bay 2, and then it will remain suspended there while Boeing disconnects this engine section transportation adapter. And then they'll do the final preps, and then they'll lift the 4/5 up into the core stage vertical integration center, and then Boeing will bolt the aft LH2 tank flange to the flange on the engine section. It only has the one on the forward end, and then that will be, and that's really the milestone, the build milestone. And then they have a lot of outfitting to do. They will some of the preps for engine installation they can do because the engine section is already in place, and so they already have a lot of the access equipment. There are platforms inside the engine section during integration, and so they'll have to remove the upper level of those platforms in order, the aft dome of the LH2 tank sits completely inside the volume of the engine section, and so there is that will have to be cleared as a part of our preps for doing that final major join and stacking the 4/5 on top of the engine section. But then they will go through. They will start making all of the connections. They will bring in the engines, and so that'll be something we'll be looking for in terms of sort of readiness for the engines, or readiness of the stage to receive the engines, because the engines are ready for install right now. It's just that they're still at Stennis, and it may be that it's just L3 Harris is the prime contractor for the engines. I think they do have some staffing in Florida, but I think most of the work on the engines is done elsewhere. So a lot of production is done out here on the West Coast in the Los Angeles area of the components. Final assembly of the engines is done at the Stennis Space Center in southern Mississippi. It's actually not that far away from Machute Assembly Facility in New Orleans. So that may be part of the equation, which is they probably don't want folks on travel budgets. And maybe, I don't know of how many of those folks want to be there, but it may be that they ship the engines a lot closer to installation time than they did for when that was done in New Orleans. Because again, one of the things, so when I was visiting New Orleans last week, the hotel I was staying in was actually closer to Stennis than to Machute. They're probably less than an hour drive, assuming you didn't have to worry about traffic away. So the folks that work on the engines could probably live and possibly do in the greater New Orleans metro area. So you can ship those over to MAF, and you don't have to dislocate or relocate your engine personnel necessarily. But when come here for testing or installation, in this case, there's that consideration that also has to be accounted for. But that will be another, again, depending on, obviously, if we get some information on, get some pictures and visuals on when the engines arrive at KSC, that'll give us a sense of, okay, they've gotten far enough into final assembly that they're ready to do the engine installs. And then there's once the engines are installed, they will be getting set up to do the final integrated functional test of the whole stage, and that's really setting the stage for completion of the stage and then handing it over to exploration ground systems, and which is somewhat of a figurative thing. But when we get all the way out to there, at some point in the second half of the year, they will have to do one of these double crane moves again. And so what it sounded like when I was asking about that was, when the stage is ready, you'll see the same thing that we saw with the Core Stage-2, which is that they shipped Core Stage-2 early enough, and that they were able to fit check and do some evaluation of that unit in the High Bay 2 facility, the new tool, and actually ended up having some servicing and maintenance work that they needed to do on the stage at the time. They were able to do it in that. And then when they were ready to stack it, the stage was lifted out of the tool and was rotated back to vertical, because the cranes can't reach from High Bay 2 sort of catty corner or diagonally across the transfer aisle. So you have to actually lift the stage out of you could move, if the integration cell was in High Bay 1, you could you could transfer the stage across over the top of the transfer aisle from High Bay 2 to High Bay 1, but you can't do that from High Bay 2 to High Bay 3. So it probably takes an extra week's worth of time, but they'll take it out of the tool, they'll lay it down flat again on these carriers, and so I believe these carriers will have to stay in Florida at least for that. So that's one of those other side questions, which is I don't know if those can be shipped on the ground, but this engine section simulator will have to go back to New Orleans, and it probably has to go back on Pegasus. And so that's, again, one of those other questions is Pegasus also has, or Boeing has, some additional hardware that they're going to eventually need to transport from New Orleans to Kennedy. And then all of this hardware will eventually need to get back to New Orleans for the next one. Although, again, plenty of time to do that. But that when they get ready to stack this, when it's completed, they'll lay it back down on this temporarily, and then the SPMTs will, just like they did about a year ago for Artemis II, they'll pick up the stage and roll it adjacent to High Bays 4 and 3, and then a second 325-ton crane will be used with the transfer aisle 175-ton crane to then once again break it over from horizontal to vertical, and then it'll be lifted into High Bay 3 to be mated to the boosters. So Steve was asking, is there a reason why some of the plumbing and some of the external outfitting is done in the VAB? Some of it probably has to do with, you just have to pick a point in production where you have to decide, can we ship it and defer some of that work? I think some of the detailing work on the exterior, and specifically, if not internally, is optional in terms of this has to be done before we ship it from New Orleans to Florida, or this is optional. Like we can do this in Florida, or we could do it in New Orleans. If we have time to do it before we ship, we can do it in New Orleans. If not, we'll ship it and finish it in Florida. One of the things I would suspect that they would have to that they had to do. Oh, and speaking of those contingency pad access platforms, there's, I think, one of them, the red coloring. It took me a while, but I just noticed that. But those have been parked outside for a while, if I recall correctly. But the systems tunnel is there's a tool in New Orleans that attaches the systems tunnel in a horizontal configuration to the to different segments of the systems tunnel, the base plates. So there's a tool where they set up the base plates and connect them up, and they set up the wiring harnesses on those before they are then laid out and spread out in the stage and in the systems tunnel. But and then there's a tool that picks that whole assembly up and rolls it in underneath the stage and then raises it up onto the exterior so that it can be bolted to the, there are bolts that go onto the metallic structure itself. And so that probably, the base plates themselves have to be attached by that tool, I believe. I don't know that they have any way of doing, they may have a way of doing individual, perhaps one or two of those in the vertical, maybe by hand, but I don't know, but I'm not so sure about that. But there it is, there's sort of a, I think it's more of a, there isn't that sort of a black and white line about what needs to happen. Some things need to be done in New Orleans, but some of these things that they've left, like the remaining liquid oxygen feed lines, can be attached in, obviously, in the vertical in High Bay 2. And so other things like, again, the foam closeouts on the inside or the outside, they obviously, on the inside, there are things that they would have had to do, they've had to do at Kennedy Space Center going back to the first vehicle. So they've always had the capability to do, certainly the internal, there's foam that is that is sprayed manually. There are molds for pouring. There's foam that's poured into molds, like around these like valve assemblies that have these funky geometries. So those types of things they've been doing inside the stage, inside the engine section and the inner tank for the first two builds, and so they can continue to do that now. The only place, well, that's actually, it's an interesting question about storing, where they would store, if they could store Starship hardware in the VAB. Assuming that some sort of an agreement could be worked out, they may be able to store, the only two places that they would be able to store it would be High Bay 1 and High Bay 4, perhaps. It really just depends on what requirements SpaceX has in terms of storage. But yeah, it's again, without knowing a lot more about what's required and what exactly benefits, cost benefits, how much that gets in the way of, if you're trying to accelerate the SLS cadence and stacking and in-vehicle integration schedule, is one interfering with the other and vice versa. So I don't know whether, again, I don't know whether, what are the advantages to one of the parties or both of them, and what are the disadvantages to both of them for that. But I think right now, yeah. So right now, High Bay 1 is being used to store some equipment, but it's not particularly large equipment. So at this point, there will be a little bit more work. I don't know exactly when we're going to lose this feed, but there will be a little bit more time once they get through the doorway, so to speak, and closed in. And then the SPMTs, they trying to remember what the name of they have these. They usually put I-beams down on the floor in the VAB. The SPMTs will lower the those carriers that the stage is sitting in or lying in, depending on your analogy, and it'll lower those down onto those high beams. And then the SPMTs wouldn't need to be used again. Really, in theory, wouldn't need to be used again until they're ready to stack the core stage sometime, in theory, later this year. But they'll just leave the stage there on those I-beams if they needed. The SPMTs would give them the option of repositioning it if they need to. But for right now, in the next couple of hours, I would assume that they're going to they will roll over those I-beams, position the carriers over those I-beams, and then lower it down onto them. And so, yeah, that's correct. At some point, Steve's talking about High Bay 4 never stacked a rocket. I believe that's correct. Certainly not in Shuttle. By the time that Shuttle started, High Bay 4 was being used as a stacking support, stacking prep facility. That was where the rail heads actually used to run into both High Bay 2 and High Bay 4, if I recall correctly. And so they used to receive the rotation processing and surge facility did not exist at the beginning of the 1980s. And so the idea, again, with that high of a cadence goal, they just planned on rolling those into High Bay 4 and doing the booster buildups in there, and then lifting them up and in. And so the other 8 segments for the Artemis III booster set are still in Utah. Really, they don't have that much work to do in what those ones will just be offloaded from the rail cars, rotated to vertical. They'll do receiving inspections, and then they'll go on pallets. In theory, you could do that one by one and just take them off the rather than they would still have to go on a transportation pallet, but rather than rolling them into a storage into one of the surge buildings for storage, in theory you could go back to that shuttle concept, so to speak, which is you could put them on a transportation pallet and then just roll them right into VAB High Bay 4 and then stack them. Or I suppose you could do something. You could even go farther with that, but the railheads, I don't believe, go into High Bay 4 anymore. And so High Bay 1, in theory, you could do that. And in fact, I believe there was an agreement, but I don't know that they ever actually signed the contract for it. And so I think, again, there was an agreement for SpaceX to rent or lease the High Bay 1 space at some point. But as is noted in the chat, High Bay 1, and this goes back to minimal infrastructure for SLS, and the politics going back 15 years or more. But High Bay 1 was one of the shuttle integration cells, High Bay 3 and High Bay 1. They used to stack shuttle vehicles in both of them, and they had permanent platforms in both of them. And when they were transitioning to Constellation, High Bay 3 was initially converted, and I think they'd planned on converting High Bay 1 for Ares 5 or both bays to be capable of stacking one or the other. But when Constellation was canceled, all of those infrastructure plans were also killed, and so High Bay 1 basically is a leftover from shuttle. It's never been renovated, so you have rusting out shuttle stacking platforms, and as noted in the chat, it's basically a shuttle stacking museum, minus a mobile launcher platform, but it is not ready to support anything except storage. It might be able to stack, or might be able to accept a Starship hardware that's just essentially sitting on the floor, but you could not stack an SLS vehicle in there, and it would cost, considering that the money, if it was really that cheap to renovate the cell, remove the platforms, and use it even as a hurricane shelter, it's apparently too expensive for the government, because nobody's ever been willing to do that. So it just sits there. It's basically rusting. It's been rusting for the last 15 years. And I don't know that I imagine that they have to check it every once in a while. And I guess as long as it's safe enough to let it continue to rust, and it's not a safety issue for the rest of the operations. But really, again, there isn't enough money in the budget to put it to use. And so that's why, and that's what I think was perhaps the hope was, SpaceX would have had the money, I think, to renovate that cell. But again, there are probably issues in terms of interference back and forth. So I would imagine that if anything, SpaceX, because SpaceX works is working at a faster pace, that they probably would have felt like, I think one of the notional contract stipulations was that SLS activities would take precedent over any renter of High Bay 1. So they would have to stop whenever SLS needed that. And so that may have been one of the reasons, along with the fact that SpaceX is building a much more purpose-built facility, if not multiple facilities, on other parts of the Kennedy Space Center grounds. So there's the first gigabay that's going up on adjacent to Kennedy Parkway. And so I think one of the questions would be today whether or not SpaceX has any desire to use the vehicle assembly building. Is there any value to them at all? And does that outweigh the drawbacks? All right, so I'm going to take. I'll be back in a second. I'm assuming this is going to be going for a few more minutes, but they're getting ready to roll it into the southern end of the VAB transfer aisle right now. But I'll be back in a couple minutes. I'm just gonna stand up and get some coffee. Okay, so it's possible that they're waiting. They're coordinating with the folks inside the VAB to make sure that they're ready. Let's see. So Steve's asking, when they lift the core stage up and over into the high bay, does it stay vertical, or is it too tall and has to be tilted? For No, it can stay vertical. So they would have to use two cranes to keep it tilted, and I don't think the cranes work that way. So yeah, they there's a limit to the dimensions of the diaphragm, so to speak. There's basically an opening in the structure of the VAB into each of the high bays, and so the core stage is short enough so that it can be a single crane can it can pass through that opening. What they did for the shuttle, and so those openings, I think, again, were they would have been designed for Saturn V, and so for shuttle, the width, the wingspan of the orbiters was such that the orbiters were rotated, they were twisted, so to speak, so that they were angled so that the orbiter could get through from a width standpoint as opposed to a height standpoint. And we saw that sequence because the core stage vertical integration center, trying to remember, it was activated. They finished construction of it in 2024. It was activated at the end of 2024. And so core stage 2 was delivered to Kennedy Space Center again in more or less it was more or less completed in New Orleans in middle of 2024. It was shipped to Kennedy Space Center in July of 2024. And then it stayed in the transfer aisle for quite some time. But then in December, it was moved into the core stage vertical integration center in High Bay 2. So they lifted it up, rotated it from horizontal to vertical, and lifted it into High Bay 2. And then it stayed there for a few months. It was lifted out of High Bay 2 at the end of March, or was it the middle of March? I think it was the middle of March. They laid it back down on these transportation carriers, and then a couple of days later, it was picked up again in front of High Bay 3 and lifted up into High Bay 3 and mated lower down in between the boosters and mated to them. And we'll see that again. The hope, obviously, is that we'll see that again later this year. Hard to tell if they're moving. I guess maybe they are moving very slowly. It does look like they're nosing through the doorway, so to speak. And so that's really going to be the next, the again, just my opinion, bigger milestone is when they pick this stage subassembly off the hardware and made it to the engine section. That's really the major build milestone, the next major build milestone. And the question is when are they going to do that? We won't necessarily see that live, but hopefully we'll see it within a handful of days afterwards. It's kind of hard to believe that it's still April. So this has been a there's been quite a few. Okay, that's funny. So I'm peeking over at the NSF NASA spaceflight live stream, and so I can see some familiar public affairs faces. They're posing with. It looks like they have a what's the name of the the zero G indicator for? They're posing with several of them are posing with they have a mascot-sized thing. I imagine you'll see some of those pictures. On the NASA on NASA.gov at some point. But it is pretty interesting. It's like not quite, but just a little bit less than 4 weeks ago. Artemis II. So 4 weeks ago today, we were on the eve of Artemis II, and so in this month we've seen Artemis II completed and have gotten several milestones for Artemis III preparations with the solid rocket boosters, with the first two solid rocket booster segments shipped to Kennedy Space Center because they have more work to do on them than the other 8 to get them ready to stack. And now we're seeing all of the core stage. So this is the balance of the core stage hardware, aside from some of the detailing on the outside. But now all of the core stage hardware is at the Kennedy Space Center and is being moved into the vehicle assembly building. And again, on a technicality, so the RS-25 engines are considered are essentially managed in a separate office. So they're actually there's a liquid engines office, there's a boosters office, and there's a stages office inside the program. Even though they are technically called, among other things, core stage engines, but the stage, all of the stage hardware that Boeing manages is soon to be completely in the vehicle assembly building, at least for the Artemis III build. For the Artemis IV core stage build, now that all of this hardware is in Florida, Boeing is still going to have to work on the core stage 4 engine section, which is also in the vehicle assembly building that we're looking at. So they have to continue to outfit that element. And then in New Orleans, the forward skirt and the inner tank were ready for application of their spray-on foam insulation on the exterior. So once they do that, then they will be set up in integration stands for their internal outfitting. And then the liquid hydrogen tank, all of the liquid hydrogen tank welding is complete. So the tank, all of the barrels and domes for the tank, all the friction stir welding of the major structures was completed last fall. I believe it was in November. And then since then, they have to do plug welds for where the pin, the friction stir welding pin goes into the barrels and the domes to do that type of weld. That it leaves a hole for each of those circumferential welds where the pin is inserted in and then is removed. So they've finished the plug welds, they've done the non-destructive evaluations, the ultrasonic testing, I think they do X-rays as well. But they do it. They inspect all the welds around the entire circumference, and then they inspect the plug welds. They do that once, And assuming it passes those, which it has, then the LH2 tank will go out to the proof test building, and they will do a dynamic proof pressure test on that, where they'll pressurize the tank, and then they will impart loads on the tank on one end. And assuming that it passes that test, it'll come back to, that's done out in a separate building for safety reasons. And then it'll come back into the main production area, and they will then get that tank ready for its thermal protection system applications. So it'll first get a full coat of primer, and then it'll get its SOFI, its spray-on foam insulation. The liquid oxygen tank is the last element. They were finishing up the final weld in the big tank welding tool, the vertical assembly center in New Orleans. That had been they had to stop for a week because they were finishing up this 4/5 assembly for the third core stage. And so then that's been gone for a week. I would assume that assuming everything was ready, that they would have gotten into that, trying to get set up to do that weld here. Once that's done, then that tank will go through a similar set of jobs. So plug welds, they'll do ND inspections of the welds, then it'll go through proof test, and both tanks will then, the welds will then be re-inspected to compare before and after proof test, just to validate that the welds are still good. And then the tanks will go through, they'll get a primer coat and then a foam application. There will be there will be some internal outfitting of things like liquid level sensors, the sump on the liquid oxygen tank, vent valves, and other equipment like that, instrumentation. And then eventually it'll go through the same final assembly methods that the third build just went through. So they'll do the forward join with the inner tank, liquid oxygen tank, and forward skirt. And then the liquid hydrogen tank, by that time, the liquid hydrogen tank will be stacked on that engine section simulator we see going through the door of the VAB right now. So that'll have to go back to, this is still a while away. But under this increased cadence, Boeing is going to need to have that fourth build done relatively soon. How this latest schedule wrinkle, or whatever you want to call it, delay, is factors into all of this, I think is to be determined. It would be for whichever elements. I think obviously leadership is going to want the different programs to continue to work as expeditiously as possible. And so it would be a good problem for the overall Artemis portfolio to have more of the SLS and Orion hardware, since they've been, at this for much longer than the lunar landers, to have more inventory. It would be hard to say they're hardware rich, but it would certainly be in a better position than they are right now. If they actually had full SLS vehicles in storage ready, more or less ready to stack before those missions, that has some value overall, but it doesn't, again, since all of these programs are more or less independent of each other, and certainly Orion production is independent of SLS production, and those two are independent of the lunar landers and the spacesuits. There really isn't the status of one of those programs doesn't affect production of the others, or overall status of the others or readiness of the others. It's just that if you operate on the assumption that Artemis III requires lunar landers, that it requires one or both of the lunar landers, then it isn't enough for Orion and SLS to be to have hardware ready to go, ready to fly Artemis III. You need to have lunar lander hardware ready to fly Artemis III as well. And so there's Teddy. It's breakfast time for Teddy. So I'm going to take a few minutes break here to help. He unfortunately also has to have insulin, and so it's not quite as easy. That's more of a two-person job. So I'll be back in a few minutes here, and we'll kind of wrap up the offload of the core stage, as it's practically all the way into the VAB at this point, almost. But I'll be back in a few minutes. Okay, well, it looks like the core stage top 4/5, the core stage 3 top 4/5 for Artemis 3 as well is now looks like completely inside the vehicle assembly building transfer aisle. They'll still be working to set it down on. I'll have to go look up what the terminology is, but there are these essentially I-beams that they'll rest, that the SPMTs will, lower it down onto. But that was about 3 hours. Of course, they've been working since before daybreak. And in fact, they took the evening off, but a lot of work once the barge arrived yesterday afternoon, and they beginning to unpack and get ready to do this offload this morning. But it started more or less at the time that we were told, which was around 8 a.m. Eastern, and so a couple of hours later, it's now inside the VAB transfer aisle, and so the next thing we'll be looking for, we don't exactly know the time frame, is for it to be rotated to vertical, lifted into high bay 2, and then eventually mated to the real engine section, which is already in Boeing's vertical integration center tool in there. But I'll go ahead and at least head towards wrapping up the stream here. I don't know that we're going to see a whole heck of a lot, and I would imagine NASA is going to cut this stream here relatively soon, unless I don't think we're going to get any live shots from inside the transfer aisle. So I'll just, if anybody has any remaining questions, I guess in some respects, if not all respects, or some of this is overshadowed, I think, by, again, the announcement or whatever it was made somewhat in passing yesterday by NASA Administrator Jared Isaacman, that Artemis 3 is now, that the lunar landers for Artemis 3 have said they could be ready. I can't remember if he said no earlier than late 2027, but that would be a delay, especially if that's all we're going to get. Again, it begs the question, it begs more details and more context. But without any additional context, a delay already only 2 months after a mid-2027 date was announced overshadows this to some degree. And so it's going to be interesting to see if we get any clarification, any additional context or not. So Trevor, Trevor's asking about the engines. So again, just talking about, I think there's going to be a lot of focus on dates for Artemis 3 at this point, and the core stage build and the Orion build are factors in that. But I think they're on another schedule. Again, based on the fact that they've done these builds before and that they've picked up the pace, they at least seemed like they had a shot at supporting mid-2027. And if you're going to start stacking SLS in the summertime, they would be, that would be, stacking SLS in the summertime would be pointing towards a mid-2027 launch date. So maybe they will delay that now too. It does beg the question, if late 2027 is the earliest you can fly that now, why you would start stacking boosters, unless it gets back, it just opens up. We're probably going to open up this can of worms at some point. I just didn't expect it to be this quickly, that the ambitious schedule for Artemis 3, 4, and 5 would be torpedoed this quickly. But if it really is, if you're really delaying Artemis 3 to late 2027, that's it just opens up that can of worms immediately. But in terms of what happens next for the core stage, so Trevor was asking about the engine. So the overall outline of the sequence for the core stage build from here is the engine section is inside the vertical integration center tool in high bay 2 right now. So it's set up. Supposedly it's ready for this mate. They will, when it's ready and when the top 4/5 are ready, they'll pick up the stage, rotate it to vertical in the transfer aisle. They'll lift it up and over into high bay 2. They'll unbolt the engine section simulator, transportation adapter, or whatever you want to call it. They'll unbolt that, and then they'll lift the top 4/5 up into the integration center tool and bolt it to the engine section. Then that will then allow them to begin doing all of the functional integrations between those two subassemblies, the engine section and the 4/5. So there's electrical, there's fluid lines, there's propellant lines. They'll start working on all those. The 4 RS-25 engines will be trucked over from Stennis Space Center in southern Mississippi. They'll go ground to Kennedy Space Center. They will be prepped for install. They'll install the engines. They'll continue doing all of the final connections for the stage. So we were talking about liquid oxygen feed lines on the outside, the liquid hydrogen feed lines on the inside, the systems tunnel, the repressurization lines on the outside will have to be, the repress lines will be welded. They'll be welded connections for the sections that they haven't finished yet. The propellant feed lines will be bolted connections. They'll be doing foam closeouts of all of those bolted flanges. The repress lines will not have to be foamed. They'll do, once the engines, they'll install the engines in the vertical this time. They'll do leak checks of the main propulsion system at that point. Make sure, leak checks of the engine connections to make sure the engine interfaces are not leaking, but then they'll do full leak checks of the main propulsion system. And then they'll go into this final set of functional testing for the whole stage, which is called Final Integrated Functional Test, or FIFT. And at that point, we're talking about probably well into the second half of this year. And eventually they will get to the point where they'll be doing foam closeouts. So you saw some of those sections of some of the flanges where they still had, you could see green, where they haven't finished doing some of the foam sprays. They'll do foam sprays and trimming and sanding. And then they'll hand the stage over to Exploration Ground Systems. The target is sometime towards the end of this year. And then EGS will have a little bit of work to do, maybe a couple 3 weeks of work. They'll need to do some, they'll need to install some flight termination system components in the systems tunnel for the core stage. And then they will do that double crane, double breakover operation again. They'll lift it out of high bay 2, lay it down horizontal in the transfer aisle again, roll it over in front of high bay 3, and then they'll lift it up over and mate it to the boosters. And in the meantime, the boosters will be stacked on Mobile Launcher 1. And so if this late 2027 date continues to track through the rest of this year or gets worse, we may see NASA pause the booster stacking, and the core stage can stay in high bay 2 in that tool indefinitely, I would imagine. So so we will see. Let's see. So John, I can certainly hang out here for a little bit. John is asking, based on the committee chairman's opening statements the other day, is there any hope that EUS Mobile Launcher 2 will be restored. I guess I would say, I think that's to be determined. I think we don't know. Whereas whether Mr. Babin, Representative Babin on the House side and the House Appropriations side, he seems to support finishing those, but it remains to be seen if there's a consensus on the side on Capitol Hill. The White House wants no part of that. So I think at best what the White House is saying is, if Boeing and Northrop Grumman and a consortium of the prime contractors for SLS want to take over complete financial responsibility for those and finish them on their own, they would be okay with that. But I'm not sure I think the question, I think, is whether one of the questions is whether they would be willing to do that, and then is Congress, is Congress interested in playing any role in finishing those at this point or not? And so that's, I think, we just don't know at this point. We may find out. The appropriations subcommittees are going to be marking up, and then the full committees are going to be marking up appropriations bills here in the next probably month. Maybe we will get some idea once we get to see the actual legal text in those, but we may not. It may take a little while longer, but I do think we'll get at least some idea about what Congress wants to do. Because it does seem like, based on the law in place at this point, I'm not sure, even though NASA leadership, I don't think NASA leadership has done anything yet to destroy Exploration Upper Stage or Mobile Launcher 2 equipment. They have frozen work, so they're definitely not progressing on it, and they are going backwards. They've started disassembling Mobile Launcher 2, but I do not believe that they've done anything that would rule out finishing those. They would obviously have, they're taking multiple steps backwards, and so if Boeing and Northrop Grumman and L3 Harris and that consortium of companies wanted to go forward again, then they're obviously going. It's going. The actions that have been taken already, I think, have delayed those being available to fly missions into the next decade, if not well into the next decade. But I don't think that's been ruled out yet. I don't know whether the White House, because the thing is, there would be some additional cost to terminating contracts. So I don't know I don't know. It's not clear exactly what everybody wants to do at this point. But it is I think the clearest thing right now is the White House position, which is they want, because Artemis V is already mandated by law and by with money to be government funded, the SLS and Orion vehicles, they're going to follow that law, but they immediately want, so beginning with Artemis 6, they do not want the government to be operating these systems and paying for them. They want to be contracting for services, and if these companies offer them as services, then that's okay with them. But they no longer want the government to have any commitments and any national. They don't want the national capabilities. And it isn't so much that they don't want national capabilities, it's just that they're really expensive and they don't want the cost of sustaining and maintaining that. And so it remains to be seen what everybody wants to do for Artemis 6. We know what the White House wants to do. We don't know what Congress wants to do. And probably more importantly, we don't know what Congress wants to spend on Artemis 6, if anything. And then again, if you get into a commercial competition for lunar crew transportation services, even if you're looking for two providers, I don't know how you set up that competition so that you guarantee that SLS and Orion. I guess the one way to do it is if they were to continue to provide the same level of funding, and it's just that you're just all of the folks that have been working on these programs, just their paychecks are written by somebody else, then that's okay. But it doesn't really make a whole lot of sense to spend $4 billion a flight on commercial services either. So I don't know what you're gaining if you were to spend the same amount of money for transportation services, whether you own and operate them yourselves or whether you're paying other companies to do that. So the flip side of that is if you're only spending, let's say, $1 billion, which is a huge amount of money, but is significantly less than $4 billion, the only companies I think that could afford to do that, if you want to afford in air quotes, are the ones that have significant government-sized financial backing externally from the government. And so that's obviously Elon Musk and Jeff Bezos. I don't think anybody else can compete with them. It'll be interesting to see how SpaceX positions for this once they go public, because then they will have to at least entertain the input from investors. But it'll still be the same as like Tesla. So the shareholders will not have controlling interest in SpaceX. They will have some, but they will have some influence, but they will not have controlling interest in SpaceX either. So, yeah, I mean, so as Eric's saying, well, I don't agree with that completely, but that I think is that's the line that we're trying to establish. When does the government end its direct involvement in human space flight? You might say that it's International Space Station, but I would say, again, those really at this point, the government is not operating the transportation services for the space station either. And so, is Artemis V the last national capability? The last time that the nation has its own capability to launch crew into space? That's I think the question right now. Even if you end up just changing the badges, but again, it doesn't really. There's an incongruity. It's incongruous to say that you're going to let a commercial contract and pay the same costs to a commercial company, when the whole point of the point of the commercial contracts is to reduce the amount of the cost. So are those companies really willing to work at 50% of what they were getting, 25% of what they were getting, 10% of what they were getting? I don't know. I mean, are we talking about 500? Are we talking about $500 million? Isn't that still too expensive a flight? So again, we need to find out what Congress wants to do. But it's I think inherent to a commercial competition under the circumstances with the industry right now, that SpaceX is in the best position for sure, and then Blue Origin would be in the second best position from a financial standpoint to win any large scale government contract where you're talking about human rating requirements. I don't even know where I would put the traditional contractors. They would have some capability to do that, but it goes back to the whole question of skin in the game. Are they willing to do what SpaceX and Blue Origin are willing to do, which is to do financial rounds of financing, rounds of private financing, and go and take on additional debt to do this? And again, is there a business case for SLS at one launch a year? It's hard to buy it. So we shall see. because it's really, I think, going to be up to, it's just hard to see. Again, maybe they can, they're going to have to convince other people besides the public that SLS can be done as a pure commercial operation, and that there's a business case for those systems. But I would be certainly interested in hearing the business case for it. So, but we'll see. I think with this static shot, it looks like the stage has been pulled in far enough to where it is. It's hard to see it now. It may still be visible, but they would have to pull it in a decent amount of ways to get in front of high bay 2 and high bay 1. So I'll go ahead and wrap up my commentary on top of this live stream is being provided by NASA Kennedy Space Center Public Affairs, and so I certainly thank NASA for providing some level of this, because it's certainly something I can't provide, and so I'm just trying to provide some additional commentary and context, hopefully, and perspective. And you can see some of the support equipment is now trailing into the transfer aisle behind the stage. So one of the things that they did, and then I will stop, but they do have the equipment in the inner tank and the forward skirt. They were keeping air conditioning on that, and of course they have to disconnect that to do the move. So they'll be trying to get those back on purge, essentially, and air conditioning / purge here as soon as they can. But they do have some period of time where they can be off of that air conditioning purge. But they'll be trying to get that set up, because I wouldn't imagine we will have to see when they're ready to do that lift and made it to the real engine section. But it might be a few days, if not weeks. So. And so hopefully, again, this is one last thing here. So Steve says, I hope we see this stage before. We should see the stage when they mate the sections together, at least parts of it. I'm hoping that we will see that lift operation. It won't be live. So maybe the next time we see this stage live is when it's rolled out. But I would hope that we see some views of it, recorded views of it, in the not too distant future, as they made it to the engine section, as they install the engines, and then as they get it ready for stacking. And in theory, that would be later this year. So I'll go ahead and wrap up the stream. Thanks for everybody for hanging out here. Not really sure. This was probably the last live event for a while, but we'll see. I wasn't exactly sure we were going to get this a week ago, so we'll see if there are any other Artemis live events to cover in the next several months. But I'll be doing more videos. I will still be doing a live stream for channel members during the week. Because they're helping support travel and sort of the more normal level of travel. I really appreciate everybody who's been here on the public live streams who've helped out. The interest has helped at least cover a significant portion of the costs, and that's really that's all I'm trying to do. And there's the end of the live stream. Let's see if I can. Let's see. I will switch over to this and I'm gonna go ahead and close this. But this is that's Artemis 4. Well, I can only put it on. This is the mission that we're aimed at, and now, of course, we don't know what the date's going to be for that. But anyway, I'll go ahead and sign off. Thanks again to everybody. Thanks for all of all of your generosity during Artemis 2
It really does help. And really what I'm trying to do is I'm trying to cover as much of this as I can, and that's really what this is for. And so if I can just break even for travel costs, that'll be great. It'll allow me to do more travel if I can. But I will continue to cover this. It's a much more cost effective to stay in one place, but sometimes you do need to travel to see things. And so, but I will be covering this one way or another. It does sound like this year is going to continue to be eventful, maybe for different reasons than Artemis flights though. But anyway, I'll go ahead and sign off now. I'll hopefully see you next time. And if you're interested in joining the channel, I will do another live stream later this week. I think maybe we'll wait and see how these congressional hearings are going, see if we get some more information about other things. And but I will also be releasing videos, try and continue to cover Artemis. If you want to continue to get coverage of Artemis every week, I will be continuing to do that. Thanks again, everybody. I'll see you next time.